Hi everyone, welcome back to our channel. Today we are going to find the solution for problem number 24. So this is the network given to us. Is asking us find the current in 5 ohm resistor using Norton's theorem. Okay. So this is very simple to find out. So the procedure of finding is first we need to find the current source, which is nothing but ISC, and we need to find out this shunt resistor, which is nothing but R Norton, and replace with this with the load resistor, where this is nothing but RL is equal to 5 ohm. So the current in this branch I can find out like this. Okay. So therefore IL, the formula of IL using current division rule is equal to total current ISC. So in this branch I want what is the parallel branch, which is nothing but R Norton divided by R Norton, the sum of resistors which are connected in parallel, R Norton plus RL. Now look at this problem. So first what we need to find out is ISC, and second we need to find out is this one. Okay. So now I'm going to find out ISC. Okay. So I'm activating the source, 10 volts, 3 ohm, 6 ohm. I have a current source of 1 ampere and one more resistor of 10 ohm. And what happens here is, what we need to do is we have to short circuit this branch, and I need to find out ISC. So this is the voltage at this point is 10 volts. The voltage at this point is 0, 0, 0, and 0, and this is also 0. Now this is a known voltage, and here automatically a new voltage will be created at this point. So now let us try to see how the currents are flowing. So this is one branch. I am marking this branch current as I1. This is another branch I2, and already one incoming is there. This is another branch which is nothing but ISC. Okay. So in order to understand more, I'm going to apply nodal analysis at the node Ex. Identify what are entering currents and leaving currents. So you can see here 1 ampere current is entering. What are the leaving currents? I1 is the first leaving current, and next this is the another leaving current, which is nothing but I2, and another leaving current is ISC. Now we need to find the value of Vx. Why? Because the formula for ISC, how to find the current ISC? So what is the voltage at this point is Vx. Vx minus 0 divided by R. What is the R value? 10. So when you perform Vx by 10, automatically I can find out ISC. Okay. So in order to find ISC, I am finding Vx. So here I should write down only Vx term. 1 is equal to, how to write down the current I1? The current I1 is flowing in this branch. So this is nothing but plus Vx. Current is leaving, what is the leaving terminal? Vx. And what is the terminal we have here? Minus Vx minus 10 divided by R. R value is how much? 3. How to write down the current which is flowing in this branch? Okay, so here the current is flowing. How to write down the current? So Vx minus 0 divided by 6. Okay, plus how to write down ISC branch? Vx minus 0 divided by 10. Okay, so now I would like to segregate the terms, and I would like to find out each and individual value. So this value is 1 plus 10 by 3, and I am taking Vx as an common term. When you take Vx as an common term, then we are going to get 1 by 3 plus 1 by 6 plus 1 by 10. when you use your calculator, then you are going to get the Vx value is 7.265 volts. Okay, how I can find out ISC is, so the current in this branch is 7.265 divided by 10. When you divide by 10, this will go with this side, you come to the left hand side. 0.7265 amperes will be the value of ISC. Next, how to find out the Norton resistance or internal resistance. Already you can see here the given problem are independent sources. For independent sources, the procedure is well defined. If you have a voltage source, what is given in the problem is 0, deactivate it. Deactivating it is nothing but making its potential as 0, which is nothing but indirectly make it short circuit. If you have current source and what is the magnitude of current, 1 ampere, deactivate it. Okay, so deactivating it is nothing but making it like an open circuit, making current is equal to 0. So now use this and find out R Nortons. So R Nortons is equal to, so very simple procedure, no need to worry. So when you look at the network, so here this is voltage source is there. This voltage source will act like an short circuit. Okay, so voltage source is short circuited, and here we have 3 and here we have 6. Okay, and now current source is there, that will act like an open circuit, and here we have the another branch which is nothing but 10 ohm, and this is how our network resembles. So remove the load resistor and look into the load resistor from the removed terminal. So when you see here, the current flows in the 10 and the current is going to divide. When the current is going to divide, I can say these two are connected in parallel. Okay. So whenever these two are connected in parallel, I will get one more branch like this. So let us assume this has some node 1 and this has node 0. So now I have 1 here and I have 0 here. Between 1 and 0, these two are connected in parallel, then I'll get one resistor. So that resistor value is product of that resistance. What is the product? 6 into 3 divided by 6 plus 3. Okay, and I have another resistor connected between these two, which is nothing but 10 ohm. So this is 6 into 3 divided by is nothing but 6 3s are 18 by 9, we are going to get it as 2 ohm. So okay, again you can see here the current flows in 10 ohm and current comes out. I can say now two are these two are connected in series. Okay. So these two are connected in series. Therefore, we are going to get only one resistor between 1 and 0. So whenever these two are connected in series, this is nothing but 10 plus 2. Here you are going to get 12 ohm, and this will be the value of Norton's resistance, which is 12 ohm. Okay. So Norton's resistance is equal to now 12 ohm. Same circuit you have. So what is the ISC value? 0.726 into Norton's is 12 divided by 12 plus 5. Solve it, then you get 0.508 amperes. Very simple. The problem is, if you are understanding the problem, so just I short circuited the branch. After short circuiting, I had find this unknown voltage. Why I short circuit this ISC, I can write down it as Vx minus 0 by 10. Automatically I can get it. So in order to find this ISC, I need to find out Vx. That's why I applied nodal analysis at Vx. I taken all these currents are leaving and entering current, and I find Vx. Just substituted the Vx here, I find ISC value. And the next part what I had done is, in order to find out R internal, this voltage source I have been deactivated. So this will act like an, so this complete branch, okay, will act like an short circuited, and this complete branch will act like an open circuit. So this is what I drawn, and I identified this current is entering, current is dividing, these two are connected in parallel. So parallel value is 2 value and already existing is 10. Again these two are connected in series. So substituting all these values here, you can find out the load current for the given problem. So this is how we get the solution for an using Norton's theorem. You can use conventional method of finding the solution also, but this is the way of finding using Norton's theorem. Hope the content is useful. If you feel my explanation is good and very clear, please like the video, and you can, those who are studying the same subjects, share with your friends. And if you have any doubts, let me know in the comment section. And if you are watching the channel for the first time, subscribe to my channel with the name KV Tulasiram, and kindly support this type of free channels for the development of students as well as for the faculty. Still, if you have any doubts, we will directly meet in online session. Thank you for watching. Viewers.